what exactly this is. So I'll draw again a circular motion, a big diagram. The only problem with me till it is perfect circle, I'll keep on drawing. चलेगा ये हम थोड़ा सा टेढ़ा है So again this is radial. Here velocity is in this direction, velocity v. After some time it has moved to. Please remember, velocity vector is always perpendicular to the radius vector. Is always now we are doing nothing about this. If I have to find a particle is moving in a circle at particular instant, its velocity is v1. Here it goes after time t here, traces certain angle theta here, and then let's say it traces a distance l. I will not take dx and dt because that d will be a lot of confusion. Because dt, when I say dt is a small change in time, it is not d, okay? So I will not take that very small. I will take a particle as moving with the velocity v1. This velocity is constant. Suppose it is moving 10 meters per second. So that is always the same. But when at this distance, if I take a photograph, I see that the particle is here and its velocity, if I cut this, suppose this is a stone type, and at this moment when it comes here, I leave it, the stone will go straight. That is the direction along shows the velocity is here. If I cut the same stone, a thread here, it will go here. So that shows the velocity here is along this direction, velocity is here. So there is a change of velocity. Now what I do, I take a vector v1 outside. I can take it because you know equal vectors I have told you. We can take this v1 outside, and from this point also I can take an equal vector like this, v2, and if the direction is like this and I take this vector like this, then I'll take like this, so then I'll take delta v, change in velocity. I can take like this also, this also. For my convenience I take like this. Magnitudes are same, okay? So if I take a vector like this, if you get from here, you will get v2 minus v1. I will not put an arrow, is equal to delta v. Angle, if the angle between these two positions is theta, this angle also has to be theta, because there is a theorem that the angle between the two lines, let us say theta, is also the angle between the perpendicular lines. If this is perpendicular here, and if this is a perpendicular, and if this is a perpendicular on this line, and this is a perpendicular on this line, if the angle between these two lines is theta, this also is theta, you can prove it. So if this angle is theta, this angle is also theta. This is the first relation which you should know. Since I have introduced dv here, I have to use d theta here. Now, what is the relation between this and angle? You know, dl is equal to, what is dl equal to?
Theta.
And dl is equal to r into d theta.
R into d.
Is it right or wrong?
Yes, sir. Right.
If I take this also as a triangle, if I take this as a triangle, they are two similar triangles, then the ratio of corresponding sides should be same. If I have to take a ratio, I take a ratio of delta v corresponding to this, because this is opposite to theta.
D.
I'm writing d theta also. So here opposite to theta is dl. So the ratio of these two is equal to one of the velocities, let us say v1, divided by r. If you take this equation, take this dl here, I do it here, divide both sides by dt, this thing also will become v1. Or if you take only magnitude, this will become v square upon r. And this is your acceleration, which we call centrimeter acceleration. Acceleration directed towards the center. If you take a piece of stone trying to thread, make a loop like this and put your finger and rotate it. If you leave it, it will go. But what keeps it tying?
Inward and outward.
Eh?
There's an inward and outward.
Let me try to understand. At this position, what has made it to move inside? What has made it to move from here to here? It should have gone straight. The pull of your thumb. That is the acceleration which you are giving. What do you call it? Direction of the acceleration. If it has moved instead of going like this is exactly same thing. If this is Earth, this is my India, and here is a satellite is moving like this. Satellite keeps on moving around this. I have to make a better India. Something. I can make a very good India. It should look like India from the satellite. Okay, here is somewhere Australia and so on. See, the satellite is moving around this. The satellite, according to Newton's first law, it should go in a straight line. It should go straight here. So, instead of going straight, it has come from here to here. What has made it to go down is the gravitational force of attraction. If the attraction would be this and this, gravitation stop, satellite will go. Same thing is happening here. There is a force which is provided by the tension of the thread. You can feel that force on your finger acting downwards. Something is brought like this. If satellite is here, it will go straight. But we know it has moved here. So from here to here, what has pulled it down is a gravitational force. So same thing is happening here, that the tension of the thread is providing that force. If you compare this, so ultimately you should know that the centrifugal force is mass into acceleration m into v square upon r. Don't take v1, v2 because the magnitudes are same. So this is the magnitude of the force. Now how do we know that it is directed towards the center? Check it from here. Check it from here. Delta V from here is perpendicular to V1. So I'll say something like this. So this one I am showing you, this one here, this one. Now this one I am shifting here. It's acting like this. Okay? Now, try to understand. If this angle is not 90 degree, if I take V1 equal to V2, what will happen? D theta will become 0. At a particular time only, we have talked that if I take this point back here, what will happen to this? If I take this point back, this will become small, and here it will become perpendicular. If these are exactly equal, if this is exactly equal to this, so it should have been coming here somewhere. ठीक है? और अगर मैं ऐसे लाइन ड्रॉ करूंगा तो ये 90 डिग्री नहीं होगा, ये भी 90 डिग्री नहीं होगा, ये तो होगा ही नहीं. और ये एंगल जब मैं इसको टर्न करता जाऊंगा ऐसे करके, when it has reached from here to here, it has reached from here to here, this line which was like this will go like this, and when I merge this, this will become 90 degree. So the rate of change of velocity at that time, which is acceleration, is perpendicular always. So what is the direction of this? So direction of acceleration at this point is like this. Direction of acceleration is like this. This is just something about, so many things you can do on this. Okay, numerical is there. Only one part is very important, is how sometimes they say what happens to a body when it is, they will show that the acceleration of a body moving is a constant velocity in a circle, means velocity is changing, though speed remains same, has an acceleration directed toward the center. So itna hi karna hai, you are not used to it. So you have to do all these things. Now what I want to tell you, why I am talking about it now, very important concept, moment of inertia, because some numerical will come on this. Suppose there are two bodies. So I will write here moment